Today, I am solving Cambridge A-Level Physics Paper 2, October-November 2022, variant 22, and it is from this examining body. At first, question 1, A. State what is meant by work done. Work done is the product of force and displacement in the direction of the force. Now, right, work work done is the product of force force and displacement in the direction of the force. At part B, use your answer to A, determine the SI base units of power. Power, unit of power is unit of power is Newton meter per second. Newton meter second. This is unit of power, and this is in fact derived unit. And for Newton, write kg meter per second square, and here is a meter, and second to the power minus 1. This whole thing gives kg meter square second to the power minus 3. Now write kg meter square second to the power minus 3. Part C, the maximum useful output power P of a car traveling on a horizontal road is given by P equals to dqb, where V is the maximum speed of the car and B is a constant. For the car, P equals to 84 kilowatt plus minus 5%, and B equals to 0.56 plus minus 7% in SI units. Calculate P. From this equation, V equals to cube root of P by B, and value of P is 84 kilowatt, and converts it into watt by multiplying 1000 and divided by 0.56. This gives using calculator 53.13 53 meter per second. Right, 53 meter per second. Determine the absolute uncertainty in value of B, value of V. And the uncertainty of B is 5% and B is 7% respectively. Therefore, percentage uncertainty of P is 5% plus 7% divided by 3. This gives 4%, and this is numerically equals to 0.04. Now, absolute uncertainty is absolute uncertainty (53 into 0.04) equals to 2.12, and this is plus minus 2%. Now write plus minus 2%. I am now at question 2. A spherical balloon is filled with a fixed mass of gas. Small block is connected by string to the balloon as shown in figure 2.1. The block is held on the ground by external force so that the string is vertical. Density of the air surrounding the balloon is 1.2 kg per meter cube. The upthrust acting on the balloon is 0.071 Newton. The upthrust acting on the string and the block is negligible. By using Archimedes principle, calculate radius of the balloon. Upthrust act in this direction. This is upthrust, and to solve this, at first I have to find the volume of the air displaced by the balloon, and it is 4/3 pi r cube. This is the volume of the balloon, this volume of the air displaced by the balloon, and its mass is this volume multiplied by 1.2, and its weight is multiplied by 9.81. Using Archimedes principle, this equals to upthrust is 0.07. If I calculate this, R equals to cube root of 0.071 into 3 divided by 4 pi into 1.2 into 9.81. This gives, using calculator, 0.1129. This is 0.11 meters. 0.11 meter. Total weight of the balloon, spring, and the block is 0.053 Newton. The external force holding the block on the ground is removed so that the released block is lifted vertically upward by the balloon. Calculate the acceleration of the block immediately after it is released. At first, I calculate here resultant force acting on this whole thing, balloon, spring, and block, is up first minus weight of the combined object. Up first is 0.071 and weight is 0.053. It gives 0.018 Newton. Now, apply Newton's second law. The resultant force equals to sorry, I have to find the mass of the combined object. Mass of the combined object is mass equals to weight divided by acceleration due to gravity. It is 5.4 into 10 to the power minus 3 kg. Now apply Newton second law. The resultant force equals to 0.018 equals to 5.4 into 10 to the power minus 3 A, and A equals to, using calculator, 3.33 meter per second square. This is 3.3 meter per second square, right? 3.3 meter per second square. I am now at part C. Balloon continues to lift the block, and the string breaks as the block is moving vertically upward with speed of 1.4 meter per second. After the string breaks, the detached block deeply continues moving upward before falling vertically downwards to the ground. The block hits the ground with a speed of 3.6 meter per second. Assume that air resistance on the block is negligible. By considering the motion of the block after the string breaks, calculate the height of the block above the ground when the string breaks. This phenomenon can be modeled like this way. This is the height, and here spring breaks, and the block movement can be shown by this way, from here here. And we know from the motion, the equation v square equals to u square plus 2as, and in this case v square is 3.6 square and u square is 1.4 square. Since its direction is opposite to the direction of this, therefore minus is before 1.4 plus 2 into a is replaced by g, 9.81, and s is replaced by s, and s equals to 3.6 square minus 1.4 square divided by 2 into 9.81. This gives the height if I calculate using calculator. It is 0.56 meter. Now 0.56 meter. At part 2, the string breaks at time t equals to 0, and the block hits the ground at time t equals to t on figure 2.2, sketch a graph to show the variation of velocity of the block with time t from t equals to 0 to t equals to t. Numerical values of t are not required. Assume that v is positive in upward direction. We know initial velocity is 1.4. This is 1. 1.4 is here. 1.4. And 3.6 is minus 3.6 is here. Now, a straight line this is the straight line, and you draw this straight line using scale, and gradient of the straight line represent the acceleration due to gravity since it's constant. Therefore, the shape is a straight line. Now I am at question 3. At part A, state what is meant by center of gravity of an object. Center of gravity of a body is the point through which its weight acts. Now write center of gravity of an object is the point through which its weight acts. And now at part B, uniform beam AB is attached by a frictionless hinge to a vertical wall at end A. The beam is held so that it is horizontal by a metal wire CD, as shown in figure 3.1. And length of the beam is 0.96 meter and weight is 23 Newton. A block of weight W rests on the beam at a distance of 0.2 meter from end B. A wire attached to the beam at point D, which is a distance of 0.4 meter from end B, wire exerts a force on the beam of 45 Newton at angle of 37 degree to the horizontal. The beam is in equilibrium. Act 1. Calculate the vertical component of the force exerted by the wire on the beam. Vertical component is resolving this 45 Newton force vertically gives 45 sine 37 degree. Now write vertical component (45 sine 37 degree). If we calculate this using calculator, this gives the value of 27.08. This is 27 Newton. Now write 27 Newton. By taking the moment about A, calculate weight of the block. Calculate the weight W of the block. Let's see the situation here. If I take the moment about A, and this distance is half of 0.96 meter, therefore this is 0.48, and this distance is 0. If I calculate this 0.96 minus 0.40, it is 0.56. Therefore, this distance is 0.5. Oh, they has given you don't need to calculate, it has given here, and I just find this distance. This is this is 0.96 minus 0.20 is 0.76. Now taking moment about A gives moment about A gives 20. This is in fact clockwise moment, 23 into 0.4, 0.48 plus W into 0.76. This is clockwise moment. This, and since the it is equals to the anti-clockwise moment, and anti-clockwise moment is 27 into 0.56, 0.56. And this gives W equals to 27 into 0.56 minus 23 into 0.48 divided by 0.76, and it is, if I calculate using calculator, it is 5.368, 5.4 Newton to 1 decimal place, 5.4 Newton. The hinge exert force on the beam at NA. Calculate the horizontal component of the force. The case is like that. Okay. Here is 37 degree. This is vertical component, and this is horizontal component, and this is hinge. And if the value of this force is 45 Newton, this horizontal component, right? Horizontal component equals to 45 cos 37 degree equals to 35.93 is equals to 36 Newton. Now write 36 Newton. Part 4, the block is now placed closer to the point D on the beam. State whether the change will increase, decrease, or no effect on the tension in the wire. This is the wire actually, and here is the weight. The point D is, here is point D. If this move closer to this, total 20, here is 23 Newton. Total clockwise moment decreases, and since the beam remains equilibrium, total anti-clockwise moment also decreases. Therefore, tension would decrease. Therefore, write decrease in tension. Now part 5, the stress in the wire is 5.3 into 10 to the power 7 PA, where P is Pascal, unit of pressure, unit of stress is the same. The wire is now replaced by a second wire that has radius which is 3 times greater than that of original wire. The tension in the wire is unchanged. Calculate the stress in the second wire. This is actually tensile stress and is denoted by sigma, and stress equals to force by area of cross section of the wire. It is in fact pi r square. And for the first case, this is 5.3 into 10 to the power 7 force divided by pi r square, and consider this as equation 1. And for the second wire, consider sigma 1 equals to force, tension remains unchanged. Therefore, since radius is 3 times, therefore pi 3r square, area of cross section, equals to 9 pi r square. Right, 9 pi r square. And consider this as equation 2. If we divide equation 1 by equation 2, let me erase this. Then 5.3 into 10 to the power 7 divided by sigma 1. This whole thing will go, only 9 is left here. Therefore, sigma 1 stress in the second wire is 5.3 into 10 to the power 7 by 9. This, if I divide this by 9, this gives 0.588 into 10 to the power 7. Now in a standard form, five point 9 into 10 to the power 7 Pascal. Sorry, 10 to the power 7, not 10 to the power 7. It is 10 to the power 6. 10 to the power 6. This is the stress of the second wire. And write 5.9 into 10 to the power 6 Pascal. Probably this is the, yes, this is the last portion of this question 3. and this class is uh, I previously this class is it contains question 1 to 3, and now now I have to finish my class here, and those students, those who think this class is beneficial for them, can subscribe my channel, and my best wishes to you all. Khuda Hafiz.